So our next speaker is Miss Huiying Lai. She's an application engineer at Seed Studio China. She is in charge of integrating Wire Terminal for tinyML into CodeCraft, a graphical programming platform. Today, she's going to talk about graphical programming for tinyML, the easiest way to start with embedded ML. Please.
Hello, everyone. Thank you. Thank you for joining us today. I'm Huiying Lai, an application engineer working at Seed Studio on machine learning application for embedded devices. Today's topic is graphical programming for tinyMLs, the easy way to start with embedding machine learning. At the beginning, I would like to show you a video. The letter S, the letter E, the letter E, and the letter E, the letter D. And this is our device, Wire Terminal. And we can use Wire Terminal to identify the motion of these three letters so as to form our company's name. And how to do that? Let's find out the secret of it. Yes. First of all, we need to prepare three things: the website, CodeCraft, and the device system, and our device Wire Terminal. If you don't have the Wire device system, don't worry. When the device system is needed, a pop-up window in the website will be sure to guide you how to install it. And then we can start. Machine learning is a branch of artificial intelligence that focuses on building applications that learn from data and improve their accuracy over time. This process is carried out without using traditional rules-based programming. Machine learning enables machines to work by observing, classifying, and learning from mistakes, just like human beings. So what's tinyML? Tinying in tinyML means that the machine learning models are optimized to run on very low power and small footprint devices, such as various microcontrollers. As we all know, microcontrollers has a lot of advantages. Ubiquitous, small, consume small amounts of energy and cheap. And thanks to recent improvement in model optimization and emergence of frameworks, especially created for running machine learning model inference on microcontrollers, it has become possible to give more intelligence to these tiny devices. The device with embedding microcontrollers can be used to give new life and meaning to old sensors, such as using an accelerometer installed on a mechanism for anomaly detection and predictive. The possible of tinyML are truly huge. Of course, it has the limitation. The main limiting factor is RAM and flash size of MCU microcontrollers. No matter how you well optimized, you won't be able to fit that Euro 9999 into a tiny microcontroller. We need to clearly know the size of our machine learning model we have built. In other words, what kinds of mission we can achieve our tinyML. However, as a beginner, we don't need to worry about that with our Wire Terminal and CodeCraft. Let me detail the Wire Terminal and the CodeCraft and how to use Wire Terminal to achieve our tinyML. Wire Terminals
there's a small icon block on the left part of the presentation. So if you can get rid of it, yeah, cool, thanks.
Where is?
Now it's gone. Oh, it appears again. So there is a icon box on the left side.
Icon box. I don't know how to.
Okay. Well, I think it's
actually here?
It's on the left middle part. Yeah, it's like there is a people.
Okay.
Yeah, it's gone now. Yeah.
Okay, thank you.
Thanks.
I'm sorry. Okay. The Wire Terminal runs at 120 MHz or up to 200 MHz. 4 MB external flash and 192 KB RAM. having the advantage in building tinyML project. It supports both Bluetooth and Wi-Fi, providing backbone for IoT projects. And the wireless terminal itself is equipped with a 2.4-inch LCD screen, so that with a simple program, we can get the displays we want on the screen. The wireless terminals has a built-in module, accelerometer, microphones, light sensor, and so on. On top of that, it also has two multifunctional groove ports for groove ecosystem and 14 Raspberry Pi compatible pin GPIO for more add-on, so that you can build tinyML project with your creation, giving new light to your old sensor. Okay, what is groove? We can see that groove is ready to use to access. It takes a building block approach to assemble the electronic. Compared with the traditional complicated learning method of using a blackboard and various electronic components to assemble a project, Groove simplified the learning process, and the Groove has a uniform interface, so just plug and play it. Every Groove module adjusts a single function, such as a simple button or a more complex sensors. For more details of the Groove and the wireless terminal, please check this link. And software-wise, we will be using CodeCraft, a graphical programming platform powered by Edge Impulse. tinyML is easily accessible for beginners using CodeCraft. It provides a user-friendly web interface and a toolkit for the whole tinyML pipeline, starting from data collection all the way up to the model deployment and extensive use. How? So let's quickly go through how to use CodeCraft to achieve our machine learning journey. First, please open the website and click the icon of the wireless terminal to enter it. And if you are a new user, you need to sign up first, then look at the left of the page. All machine learning processes are composed of 4 steps. So we can build our own tinyML application step by step. First step, model creation. You can create a model here by selecting the sensor you are going to use. As you can see, the CodeCraft provides 4 tinyML model frameworks, 3 wireless terminals built-in sensor, and a Groove, a module that can be easily connected with jumper and without jumpers and server. And click the corresponding icon to create a model using a particular sensor. After creating a new model, the interface will jump to the data acquisition. Yes, this interface. Look, the default data acquisition program has been provided, so you can upload it directly to start the data acquisition journey. Of course, this default data acquisition program is related to the default labels here. So you can add and delete labels. And when you use custom label, you need to change your data acquisition program too. And click on the introduction to data collection steps, pop-up window. Here, a pop-up window with the details of the data collection process will be shown. And pay attention to the wireless terminal's button location. And here, the animating GIF, which tell you how to collect data of default labels, has been accelerated. The actual action can slightly slow down. And please note the red tips here, which help you with your data collection process. And you can point the cursor over description, test for more details here. And once the wireless terminal is connected and click upload, this option will upload the data acquisition program. Start and finish data acquisition according to the wireless terminal displays. The red circles means the data is being collected. OK means data collection is complete. When you think the data set is enough or the data acquisition can be finished, click on training and deployment. Here we can see the training and deployment, the first step of tinyML. You can select a suitable neural network size, small, medium, or large. And CodeCraft provides a default parameter values for each scale of the models. You can set the number of training cycle, the learning range by yourself. But different tasks, different models may need different learning rates. So yes, we can change it by ourselves. But the default parameter values by the CodeCraft for each scale of the model is parameter recommended for this task. And so you can try them first. Now we know how to set the parameter, and after training, we can got the training result here. We can see the accuracy, the loss, and the performance on the while terminal. And if you are not satisfactory with it, you are not satisfactory with the result, you can retrain it and go back to the first step of training, set a new parameter or select another size of the neural network and click. And then until you get a satisfactory result, then click on the model deployment to deploy the ideal model. Now you can complete the program by dragging and dropping the blocks. tinyML with the free course for beginner is available. The course provides the most concise sample code. You can find the corresponding block according to the block colors. Of course, you can program by yourself. Then we can use while terminal to test the model we have trained. In conclusion, with this 4 steps, we can build our own application. Remember the application I showed at the beginning of the presentation? The whole process costs 40 minutes. Due to the time limitation and for that better demonstration of the process, I record the operation and illustration in advance.
Open the website, click on the icon of the while terminal. Click on model creation. Click on motion recognition because we use the while terminal built-in accelerometer. Enter the name according to the requirement. See it here. Click on OK, and it will jump to the data acquisition interface automatically. As the example application shows, we use 3 motions: motion S, motion E, and motion D. So we need to modify the labels. Click on the labels to be modified. Enter a new name, that's here, and click on OK. Three labels are not enough. We also need the motions idle and other motions, so I should tell the model that this class of motions should not be classified into the 3 target motions S, E, and D. So in the label screen, we click on Add. Enter the label name, idle, and others. Click on OK. Finally, we got 5 custom labels we want. Then we also need to modify the data acquisition program. Select the block and change the block name from free to S, to E, and to D. We also need to add new blocks so as to collect the data of 2 other motions left. Luckily, our while terminals has 5-way switch. 5-way switch here. Copy and paste. Ctrl-C and Ctrl-V. We also need a block sample data. Ctrl-C and Ctrl-V. If we use 5-way switch up to sample the data idle. and use the five-way switch down to sample the data others. Finally, we got a program which can sample 5 labels. Upload it. Usually it takes 10 seconds to upload. Once the program is upload successful window will appear on the screen. So we just need to wait for it. Click Rubber to close it. Then it's time to sample. Pay attention to the while terminal's button location. A, B, and C. Press button A to start that motion as. Press button A again as we need to collect enough amount of data set. Click button B to start collecting motion E. Okay, press button C to start collecting data D. And we use five-way switch up to collect the data idle. And then we use the five-way switch down to collect the data others. Others motion. Others motion. Okay, now the data acquisition is finished. Click on Training and Deployment. In this case, we are using large. It will take quite a long time to train the model. And then set the training circle to 20 and pick other default parameter value. Click on Start Training. The duration of loading varies depending on the size of the selected neural network and the number of the training circle. Larger is the network size and the number of training circles, the longer it takes. You can also infer the waiting time by observing the log. Epoch here indicates the total number of the training run is 20, and 11 rounds have been changed here. Okay, the training model job is complete. Look at the model training report. Wow. Open the web. Open the.
Okay. Actually, we saw that the accuracy is.
Click on.
Sorry. As shown in the last training performance, we've got 100% accuracy and 0.01 loss. This is not necessarily a good gesture, as it might be a sign that the neural network is too tuned for the specific data set and might perform poorly on new data. Overfitting may occur. A statistical model is said to be overfitted when it starts learning from the noisy and inaccuracy data entries in your data set. It happens when you have a large model and relatively small data set. In this case, the model memorizes all the data points without generalizing and perform poorly on new data. And I tried.
We have a good question from audience. Is it also possible to create image recognition model? What kind of ML algorithms does it support?
Not yet without wild terminal, but a person use another way to do that work using a thermal image. Yes, because it just has 16:4 past 16:4 in pixel to use it to recognize a person. Maybe the November 5th speaker will show this demo, and you can see it then.
Okay.
Thank you. Yeah. I tried this model and
click on model deployment. Once the deployment is complete, a pop-up window will show. Okay, click on OK, and it will jump to the programming screen automatically. In the programming interface, click on Use Model to use the deploy model. Here, you can see it. I want to use this block, this block, this block. This prediction, this one. Okay. Okay. Try to use your model by writing the following program. Okay, click the upload button. The first upload time is very long. It increases with the complexity of the model. The upload time for smaller model is about 4 minutes or longer, depending on the performance of your machine. So we should wait for it. Then you can check your model anywhere you want. Motion S, motion E, motion E, motion E, motion D. Yes. Congratulations, you have done it.
Actually, it performed well on my hand, but poor by others. That means the model is overfitting. What I need to do is add more data and train the model again.
Okay.
Here is the complete code I used in the video. A little change so as to display the word in the center of the wild terminal screen. And I still want to share more demo with you. the fall detection, and the daily activity recognition. We use the while terminal become a smart fall detection, detecting going upstairs, downstairs, and working. And we also use the Huiying Lai sensor to make a barcode recognition and the gesture recognition of rock and volcano. This is an application built by a designer of our company who knows nothing about tinyML or machine learning and doesn't have any programming background. And you can experience his application in the recommending apps. And we also, I added link here. These are two eye-catching applications built by two makers. It's okay. Oh.
Yeah, so we have the next speaker in a hurry.
Okay,
so
okay.
Yeah, thank you for your great presentation and the nice demo. Yeah, since we're due to the time constraint, we will not get the questions this session. So if you have any questions, you can email to Ms. Lai, right?
Yes, yeah, you can also join our Discord. It has a specific channel of tinyML for you. Thank you.
Yep, sounds great. Thank you.
We especially want to give thanks to our strategic partners, which really helped us that we can make that event possible. So we have first our executive sponsors. We have ARM, which is the Software and Hardware Foundation for tinyML. Then Edge Impulse, tinyML for all developers. Qualcomm AI Research, advancing AI research to make efficient AI ubiquitous. Sentient, end-to-end deep learning solutions for tinyML and Edge AI. And our platinum sponsors, Reality AI. They add advanced sensing to your product with Edge AI, tinyML. Then also we have Renaissance, broad and scalable edge computing portfolio. Our gold sponsors, Latent AI, adaptive AI for the intelligent edge. Maxim Integrated, enabling edge intelligence. Seed Studio, the IoT hardware enabler. SensiML builds smart IoT sensor devices from data. SynSense, building sensing and inference hardware for ultra low power embedded mobile and edge devices. And our silver sponsors, we have Aeon Devices, Deep Light, EMSA, Green Waves, Gravity Inc., HOTG, Imagibob, Mob, Geekzo, Rixon Technology, and SAP. So we really want to thank all of our strategic sponsors who will help us. And I hope you all enjoyed it and that we see you again tomorrow. Good evening, everyone.